recording this video is to demonstrate the use of SPSS for the survey I had conducted. So I had received 82 responses, and this is the file downloaded. So here we can see the number of responses. Number of responses are around 82. The initial ones, the four ones, have deleted because they were the trial. And you can see I have not collected like this. This is the time, start time, completion time, and here it is the email ID. So this email ID would reflect if there was a condition to log in first and then reply. So since we wanted an unbiased response, so I have not asked for mandatory email. And in the end, in case if they are okay, then they can share their name and email ID. Okay, so you can see these are the responses. The responses are on the Likert scale, so strongly agree, agree. So now for analysis, we have to convert these strongly agree, agree into quantitative terms. So this have been converted here. So the conversion, how to convert it is Control F, and here we get replace. So here we can write strongly agree and replace it with 5, then agree and replace it with 4. So this way we can replace all the things about the demographics like manager, supervisor, academician. So that I'll make separate file for that. We are interested in the survey response. So we'll switch over to the SPSS analysis. So first thing that we need to know is in whatever construct we have considered, the Cronbach's alpha of it, and then we need to do the factor analysis. So so this is the actually survey questionnaire. So there were totally around 11 questions. So first question was most of the activities at workplace can be done in a much better way. So this is scope for lean. Then accordingly other questions. If we see here, this is the scope for lean. The question number one. Then other things are creativity, positive attitude. These are enablers, behavioral enablers for lean, and stress change resistance. These are behavioral disablers for lean. Likewise, we have organizational enablers, organizational disablers, and one more survey I had conducted for the top two reasons for the performance affecting those parameters are affecting performance. So stress and negative attitude was result. And also one more construct is for the root cause. So this way there are actually totally six constructs. The first one is the beginning. There is a thought should be there that things can be improved. So I've clubbed this question number one and two into construct one, and disablers into construct two, enablers organizational into construct three, disablers in construct four, and the top two reasons construct five, and the root causes into construct six. So to begin with, in SPSS, we need to have first thing we need to have is this is the variable view. We can write the variable name lean scope. This is I have taken it from here. variable name is lean scope, and okay, it is a numeric label also you can give the same. And here you can see for quantitative analysis we want to convert it into numbers. So strongly agree is represented by 1, disagree by 2, neutral by 3. So this way, so we need to first in the variable view put all the variables and the associated values, and we consider this as nominal. Likewise, we paste all the like we can directly paste these values here, copy and paste it here, and fill in the variables. Okay, so there are around you can see up to workload, up to family problems. 32 variables are there, and this some are repeat like stress, attitude. Here also it is there, stress, attitude. So herein we can get total 29 variables are there, and those marked in yellow, these are the repeat ones, and this is the question and the prompts for this question. So what I've done is I've done all the analysis for construct one. What is the Cronbach's alpha, determinant value, KMO value, P value, commonalities, eigenvalue, variation, and here I mentioned for statistical validation how much should be the value. So for the 80 responses which I got, valid value should be greater than zero point 0.7 for Cronbach alpha. Determinant value should be greater than 0.00001. Likewise for everything. So going ahead with the first construct. So here in the variable view, once when you have put the variables, go into the data view, and here we can see I've already put in the data here. But I can just for demonstration I can delete all this. I will delete all this data. So I've deleted all this data, and I'll paste it from here. So I need the data up to here. So I'll copy this and I'll directly paste it into the SPSS analysis window. So paste the values here. So 82 responses I've pasted. From the variable view, we can see variables are in the column, but once when we come to data, it comes in a row. So here, whatever is in column, it comes in a row. We can see all the data is pasted here. Now, going ahead with the first thing for the result, like for each constructs, we have to find the Cronbach's alpha, and then this is done by the factor analysis. So to find the Cronbach's alpha, you have to go to analyze, scale, reliability analysis, and in this there's already something selected, so I'm taking it back, and I'll select lean scope, all these items up to job involvement. They are enablers as per the YY analysis. So here I get it statistics alpha, and then in statistics we have to tick box the scale if item is deleted. Now go ahead with the analysis. So here we can see the Cronbach's alpha is 0.746, number of items is 7. So lean scope up to job involvement. And in case if some of the item is deleted, what will be the Cronbach's alpha? So here we can see this is the maximum, 746 is the maximum. So we need not delete any item. So all the items are correlated and they are enablers for lean. So we can input this data 0.746 here. For the construct one, 0.746 is the Cronbach's alpha, and since it is greater than zero point 0.7, the scale is statistically valid. Now with factor analysis, we'll get the values for all these parameters. So next we'll go for the factor analysis, analyze dimension reduction factor, and here earlier some items were selected, so I'll take it back. And for the scale 1 up to job involvement is the first construct. So lean scope up to job involvement. And in the descriptives, we have to select coefficient KMO determinant, continue, extraction, correlation matrix we have to select based on eigenvalues. So if you want the components, like number of components or factors, if you want, you can select here. But actually, we have the factors we are already ascertained. We are just seeing the statistical validity of whatever factors we have considered. So we'll go ahead and rotation. We can choose Varimax rotation, and for scores, display the factor score, and in options, suppress all smaller coefficient that is below zero point 0.3. We should suppress so that we'll get a better view. And we'll click OK. So here we get the factor analysis. In the correlation matrix, we see determinant value as 0.142. So here we see 0.142 is the determinant value, which is greater than 0.00001. So the scale is statistically valid and can be factorized if we are interested into. Then we can see the KMO value. KMO value is 0.69. So 0.69 is the KMO value for this construct. So then the commonalities. The commonalities here are, actually we can copy this, copy as Excel, and then we can paste it like this. And then we can directly copy the values and paste it here in the result. So this is how I pasted all these values. Sorry, these values. Okay, here I had pasted the range, so I'll paste these values here. So see 0.46 to 0.77. Here we can see 0.46 to 0.77 are the values. So same thing, I'll paste it here. Earlier I thought I'll give it a range, but since for more clarity, we'll paste the corresponding values for each of the variable. So now I'll copy it from here and paste it as the values so that we retain all the other formatting. So here you can see the commonalities are zero point 0.4s and they are all greater than zero point 0.3. So this is also a good sign that the construct or the scale which we considered, all these items, they are correlated. And now comes the important aspect. So in the output, when we go for the total variance, here we get the eigenvalues and the corresponding variance. So same way we can copy this as Excel, and then we can paste it here. and then copy it from here and paste the values here. So you can see 2.89, 41.3, these were already pasted earlier. Just for demonstration, I'm pasting it again. I'll paste it as values. So same values they are. So you can see the item number one, that is scope for lean. It has an eigenvalue of 2.89, variance of 41.3%, and another creativity has eigenvalue of 1.2 and variance of 7.39. So as per the survey response, 17.39% people feel that creativity affects the improvements at workplace by 17%. So this is how it is interpreted. So likewise, we have done this for the construct one, that is behavioral enablers for lean. So then we have to do the same thing with behavioral disablers for lean. So disablers are stress, change resistance, disobedience, maybe. Disobedience here means that we have SOP in our workplace. So people need to follow that. So in case if they are not following it, so non-compliance to it. So that is what this refers to. So just to demonstrate, we'll take one more. We can take the last one here. We can take this, the root cause. So I'll now demonstrate the use of SPSS to calculate convex alpha and then calculate all these values. So I'll go here with analyze, scale, reliability analysis. Whatever we had selected earlier, we have to take it back. And for root cause, these are the items up to here. So these are the items that are coming up in root cause. Put it here in the alpha and just see scale if item deleted. We have to tick box this and click OK. So here we get the Cronbach's alpha as 0.79. So you can see 0.79 is the Cronbach's alpha. It's greater than zero point 0.7. And with factor analysis, we'll get these values. So we'll go in for the factor analysis, analyze, dimension reduction, factor analysis. So factor analysis is one more use of factor analysis is to reduce the number of variables and consider those which are important. So in factor analysis, we get the eigenvalues. So in case if we are not knowing which variables belong to a group, so then with the those variables which have eigenvalue of 1 and above can be grouped together and all others can be skipped from the group. But here in behavior analysis, we need to know the correlation. So that is why we are using factor analysis to see the correlation. And in case if you are interested in finding the topmost variables, then with eigenvalues we can go and find those as well. So I have selected so we'll be doing the factor analysis. So first we'll put back these and now I'll select the root causes. Root causes are starting from here. Okay, so in descriptives we can see initial solution, KMO, determinant, everything is clicked. Extraction, Varimax, correlation matrix, and in rotation, Varimax rotation, scores, and in options, and then click OK. So here we get okay. There seems to be some error while selecting the factors. Let me just check what is the problem. Analyze. So here by mistake we had selected this, we need to put it back. So to family problems is the last root cause. So here you can see family problems beginning with lack of knowledge. Okay, lack of knowledge, and then so now we'll get the results. So here we see correlation matrix. The determinant value is 0.02. So determinant value is 0.02, and then you'll see the KMO value is 0.651 and significance is 0.001. KMO value is 0.651, significant value is 0.001, and then we'll go for the commonalities. So commonalities are here. So we can, as shown earlier, we can copy this and paste into Excel, and then we can copy this column and paste it here. 0.710. You can see, yeah. So these are the values. So likewise for the eigenvalues and the variance. So now the eigenvalues and the variance, here is the table. So we can copy this, paste into Excel, copy as a Excel, and then we can paste these values. That is, this is the total. This is the eigenvalue, and this is the variance. So we can copy it and then paste it here. 3.38, 42.31. So 3.38, 42.31. Okay, so this is how the SPSS software helps us in statistical validity of our survey, and these are the results. So I found the results for all the constructs for behavioral enablers, and root cause was demonstrated in this video. So likewise I have calculated for all other constructs and put up these values. Thank you.